Hello and welcome, everybody. My name is Julian Martinez, Senior Developer Advocate and Common Man here at SDF. And I'm super excited to get today's session kicked off where we're going to dive into the basics of building full stack DApps using Stellar smart contracts. So this is going to be kind of like a freestyle, like ad hoc session. I don't have any slides or anything, but we will be using the getting started docs as well as an example, a common example that you may have seen building stuff in your journey throughout the ecosystem. We're going to be using none other than the Sorbonne example DApp. All right, so a couple of repos here or a couple of links here. First things first, the getting started QR code or the QR code that will take you to the link of the getting started section of the docs. And then later, maybe in the second half, when we start signing transactions, we'll transition over to actually cloning the Sorbonne example DApp, and then we'll kind of like dive into the ins and outs of that one. But for now, we'll get started with a very simple front-end read-only function call from our hello world contract. Now, let's backtrack a little bit. To get started, you're going to need to actually install the Rust toolchain, or it's going to allow you to use tools like Cargo and other Rust tools available in the toolchain. The second one is going to, or the second command here is going to tell the compiler to compile the Rust smart contracts into WASM. And the third command is going to install the Stellar CLI. So a little bit of a refresher from the last session if you haven't already done this. So you can actually scan the QR code at the bottom left right here, as I stated earlier, to kind of like help guide you along throughout this next 30 minutes to an hour or so. All right, now I'm going to make it aware that I can't see you guys in the chat because I am using a third-party app, but I'm going to go ahead and get right into it. So we're actually going to clone a pre-existing kind of like project. And for this, we're going to run the command stellar contract init. We're going to specify the directories here. Then we're going to create a space. Then we're going to say front end template. And we're going to say HTTPS. Semicolon // and we're going to say github.com /stellar. And we're going to say Sorbonne Astro, and we're going to say Sorbonne Astro template. Cool. No demo effect today. As you can see, that went into the directory that I'm working from. All right. So let's see what happened here. We are initializing the project at the root directory. We have a new cargo toml file, which actually kind of like injects a compatible Sorbonne SDK into our project here. We have an example, which we're going to need to edit a little bit later. We have our source folder, which has some components in it, right? You should see some things that maybe you recognize, maybe you don't. You have this card file here, which is just basically like a cool little front end component that you'll see a little bit later. The pages file here kind of like holds all the main logic that you'll be seeing a little bit later as well. But yeah, so let's just go ahead and keep working through the tutorial here. So first things first, we have this end example file. Now you can either copy this over and make a new one, or just edit the existing title to just say .env. And we're going to change some of the parameters here. So you see the standalone or the public Sorbonne network passphrase is actually going to target the standalone network. So we're going to erase this value, and we're going to go ahead and inject the Sorbonne endpoint here. So public Sorbonne network passphrase, or excuse me, not the Sorbonne RP. We won't be injecting the Sorbonne URL here, but the passphrase instead. So we have test SDF network September 2015 is the passphrase. It's correct passphrase for testnet. Then we're going to go ahead and change our public Sorbonne RPC URL to the correct endpoint here, which is HTTPS semicolon / Sorbonne testnet stellar.org. Okay, and we already have a Sorbonne account called Alice, and we're going to just specify the network to be testnet. All right, so let's go ahead and clear this out. All right. So what do we have here? Okay, we're looking at our what's it called? Our project so far, and we've also updated our environment file. So what we're going to do next is actually just install some of the dependencies. We're going to do that by running npm install. All right, so let's go ahead and take a look at what's happening here. All right, so nothing special here. We're just running npm install, installing uh, the dependencies for the project. Sorry. So we're going to go ahead and run npm run init for the next step. And what this is going to do is it's actually going to run the initialize.js file. So while this is loading, let's just go ahead and kind of just like take a look at what's happening here. All right, so we're processing the public key, uh, right? And then we're actually going to use that to deploy the smart contract. So we're going to use that as the signer to pay the fee for deploying the smart contract itself. All right, so we're using the CLI command, the Stellar CLI. All right, so we're going to say we're going to generate a new account, which we defined here, right? Sorbonne account equals Alice. So we're going to say Stellar keys generate, and then we're going to say Alice. But we've already done that, so you can think of this function here as kind of like recursively or redoing the step where we fund an account that we would pay for the deployment fees with. But we've already generated that. All right, and then we're going to build the files, right? So what does that mean? We're going to use Stellar CLI contract build, which is going to compile the smart contract files, right? Again, in contract down to its WASM format. It's going to store it in the target directory here. Next, it's going to use Stellar CLI contract deploy. It's going to specify the WASM file, right? And then it's going to deploy that right to testnet. Once it deploys the contract to testnet, it's going to record the contract ID, and then it's going to build the TypeScript bindings. So you see here, contract bindings TypeScript, contract ID, which is going to be the previous ID that was recorded. And let me see if I can get here just to the function itself. So you see CLI, contract bindings TypeScript, contract ID is going to be the ID we recorded, and then it's going to store that in the directory name, which we've defined here in packages. And just as a quick kind of overview, you see this function bind all, and there's also, I think there is a deploy all. Yep. So you can have multiple projects within this directory. For example, you can import the incrementer contract or incrementer project here. It'll actually compile that contract, deploy that as well, and create the TypeScript bindings for that. But for this, we're going to just use the Hello World contract. All right. So let's go ahead and take a look at the source directory here, and then let's take a look at the Astro page. Cool. So let's just go down from top to bottom. We see import card, right? And here's just like a simple kind of just card that holds all of the data. Just makes it easier to like contain some of the data that we're trying to illustrate here. We see import hello world from contracts hello world. Now, this part is pretty important because you see here that we're creating a client, and we've defined this client using certain parameters. So like, what exactly does that mean? Well, when we create a client, you can think of this as creating like a smart contract object. When we created the TypeScript bindings, we actually compiled that data to its own package, right? So what does that mean? Let's just go here into the package.json file, and you see workspaces, packages, right? And let's go back into the initialize.js file. If you see here, contract bindings TypeScript, output directory name is just going to be the name of the contract, packages, and then alias. So you see here that we're ingesting the packages directory. And when you call the command contract bindings or stellar contract bindings, you're creating on-demand NPM packages for the smart contract itself. So let's go back into index contracts hello world, import any as the client or as client from hello world. Now let's dive into hello world itself. So you see here in the packages directory under hello world in the dist directory. Let's just go down line by line and see exactly what's happening. You see some imports coming from the Stellar SDK. Well, that's because you create your own node module sets for the Stellar SD or for the smart contract here that should import the node modules from or the Stellar SDK node module. Here you can see it's clearly titled at stellar/Stellar SDK. A cool thing here is that it actually records the network data. So you see if you're using testnet as a point of data for your syntax here, you can actually reference network passphrase and contract ID, which we do uh, when we're creating the client object. And then moving forward, you see that we're defining all the functions here along with the argument. So you see hello only contains one argument, which is 2, and it's defined as a string. So this makes it really easy to kind of just like create front end components that leverage the methods on the smart contracts themselves. The bindings function that comes with the Stellar CLI makes it easy to transform these smart contracts over from Rust version over to the front end version after it converts the code to the JavaScript or TypeScript output. You also have these like backup or like the supporting SDKs to communicate with the Stellar blockchain, all abstracted away from your development process, saving you a bunch of cycles. Long story short, it's a really good tool. I love it. I love using the Sorbonne or Stellar smart contract bindings personally. And yeah, it just really saves a lot of time. So let's do a recap of what happened in line 4. We're importing hello world from contracts hello world. And here you could see that we're using the client to define hello world, right? Let's dive into the hello world directory a little bit. As you can see here, again, we have our own node module for the smart contract, and it includes the Stellar SDK, which is going to help communicate with the Stellar blockchain. It also contains information about the network. And last but not least, it contains all of the methods included in the hello world smart contract. All right, so let's go ahead and see how we're going to leverage this. So you see const result equals await hello world dot hello. All right, so simple enough. We're awaiting a function here, and the method is hello. We're going to define the front end, or we're going to find the message as 2. All right, so we've already run the initialize function. So let's go ahead and run npm run, and we're going to say dev. I think this is going to run the initialize function again. All right. All right, 4321. All right. Let me go ahead and drag this on over here. Make sure. Okay, cool. So you guys can see, you guys should be able to see the screen here. All right. So we see hello you. To get started, open the directory source pages page and tweak the welcome to Astro message above. I don't think that really applies to us. So const result equals await hello world, hello to you. Let's say hello and world. An error occurred. Must be a host value. So believe it was the exclamation mark. All right, cool. So we have hello world. So we're actually able to change that. We're able to do this because we're not actually making a call to the back end. So we're just using a simple JavaScript kind of like manipulation, and we're able to see the changes immediately thanks to Astro. So this is I don't know if this is exactly exclusive to Astro, but this is like a way that you can easily test the outputs of your functions. For example, in this case, we changed the hello world call, the to argument from world. We can even say like stellar, right? So it's a good way to test your functions on the front end. Very lightweight, doesn't involve any communication with the Stellar blockchain, right? So that's a quick intro, but let's take it a step further because that's not all we want to do here, right? We actually want to take this a step further first by seeing if we can read some wallet data. So I'm going to open up Freighter. All right, so you can see I'm connected to the testnet. You can see my address is GA75ZKTV. Okay, cool. So let's go ahead and see how we can connect our wallet data to the front end here. And we're going to use Freighter. So first things first, we're actually going to install the dependency. I don't think we have it yet. We're going to say npm install @stellar/Freighter API. And here we're going to create a component. We're going to call this connect and connect, and we're going to one last time connect Freighter, and we're going to say .astro. And for this, we're going to create a couple of things. We're going to create a div, and then we're going to give it a style, and then we're going to give it a script. So we're going to say div, and we're going to say ID equals Freighter dot wrap, and we're going to say, all right, stick with me, y'all, class, and we're going to say equals. Let's see if Copilot saves me here. We're going to say aria live equals, and we're going to say polite. Cool. We're going to close that div out, or we're going to keep that div open. Actually, we're not going to close that out yet. And here we're going to give another div. We're going to say div class, and we're going to say ellipsis. Here we're going to close this out. Then we're going to say button. Yeah, let's close that out. And we're going to say data connect aria controls, and we're going to say equals Freighter wrap connect, and it should say button. This needs to be in quotes. Should be good so far. Cool. So we're going to create some divs here, and we're going to get set up with our kind of like environment, if you will, our front end environment for hosting the little area that we will contain the wallet information in. So let's go ahead and give this a style real quick. So let's say style, and we're going to want a wrap, right? I'm going to say wrap, and we're going to say text align, and sure, why not give it a center text align? That's cool. We're going to close this out here. We need to bring this down a little bit. Okay, and then we're going to give the ellipsis a some values here, and we're going to edit the line height. Line height is going to be about 2.7 REM, and here we're going to say margin. This is going to be auto, and here we're going to say max width, equals 12 rem. Here we're going to say overflow is hidden. Here we're going to say text overflow, and we're going to say ellipsis, and we're going to say text align, and text align equals center, and last but not least, but we're going to say white space, no wrap. All right, so now we've got our style defined, and let's keep on moving forward. Thanks for sticking with me so far. Let's go ahead and define this script. All right. So we're going to get into some of the logic behind using the or some logic that involves using the Freighter API. So first things first, we're going to go ahead and define this the imports that we need. So we're going to say import, and we're going to say we need is allowed, we need allowed, we need get user info. All right, let's go ahead and dive into what this one actually means. So here is where you're going to get the public key from the Freighter API. So you actually have to have Freighter installed on your local machine on in your browser for this to work. And you can actually do that by visiting the Freighter website. There should be some download links to quickly add it to Chrome. But here is the function that's going to get the public key that we will be using we're going to be using this function to show the public key on the front end of the DApp. All right, so now that we have that imported, let's go ahead and keep moving forward. So we have const wrap equals document get element by ID. And no, we're just going to say query selector. We're going to say query selector Freighter wrap. I actually want this to be hashtag right there. Okay, cool. We're going to say const button query selector data connect. Here we're going to say const. We're going to say const ellipsis equals. We're going to say document, and for this we're actually going to say document as well. Document query selector ellipsis. We're going to say at Freighter wrap and ellipsis. Cool. All right, so we have our wrap defined, our ellipsis defined, and our button defined. Let's go ahead and get into defining some of these functions here. We're going to say async function get pk. It's not going to take in any arguments. Let's go ahead and see what is here for us from Copilot. This is definitely not right, but very close. We're going to say const, and we're going to say public key await get user info. Too easy, and we're going to return the public key. All right, now we're going to say async function, and we're going to say set logged. Set logged in, okay? And we're going to take in one argument. That's going to be the public key. Public key is going to be a string, okay? All right, set logged in. Public key is going to be of the type string. Now we're going to define some of the functions here. We're going to say the inner HTML is going to be, we're going to say signed in as, right? Why not? We're going to say signed in with, and we're going to define this value here as the public key value. Is that not correct? Signed in with, and then, oh, I need to close this out. Too easy. Using the wrong kinds. There we go. Cool. Wrapped. Okay, and then we have here, we're going to say ellipsis title. And we're going to say equals public key. Cool. Ellipsis HTML, ellipsis inner HTML, ellipsis set title. Do we not have this? Dot ellipsis ellipsis. Sorry, y'all. Quick spell check. Gonna fix some stuff here. Ellipsis. Oof. All right. What do we got here? What do we got here? Div class. Why is this failing? Ellipsis title public key. All right, let's just move forward because I did have some errors earlier that I was just kind of working through. So let's say, but these errors did not affect the output. Let's just see what happens. Let's keep working through it and see what happens. So as you can see here, Copilot has created a handy dandy function to complete the script. We're going to say if is allowed is true. We're going to say we're going to set the constant. We're going to set the public key to const public key. We're going to await that. We're going to get the public key there. We're going to say if public key, we're going to say set logged in to the public key value, or else we're going to wrap the inner HTML and we're going to say freighter is locked. So so let's go ahead and do this here. If public key, set public key logged in, and we're going to say here, you can just kind of go in with Astro and just type in the ternary statement itself. You say else wrap inner HTML. Sure, we'll say error getting public key. Why not? Okay, if public key, and we're going to say set logged in public key HTML. Okay, and then we're going to say else. Here we're going to say, yeah. So we have some good legs to stand on here. We have button add event listener, right? Click async function. That's true. This is all good. I'll just get rid of this. Maybe that wasn't as good as I thought. Button add event listener, and let's say I'm going to disable that button. Equals true. Kind of want that button to disappear real quick. Then we want to say await set allowed. Then we want the constant public key to be the return data of the function that we call earlier. Then we're going to say set logged in public key. All right, so we should be all cleaned up here. All right. And again, I am having some issues on my side with the like the errors and things like that. But let's just go ahead and see if this runs anyway. All right, so let's go ahead and run dev one more time. Again, thank you all so much for being here with me, and thanks for hanging out. I know these things kind of like run on sometimes. I never expect them to go as long as they do, but they always exceed my expectations. And let's see what happened here. All right, let's go 4, 3, 2, 1. Doesn't look like that was implemented because we never went to the index page. All right, so next up, we have to actually import our connect freighter button. So let's say import, and we'll say connect freighter from components connect freighter.astro, and we're going to just kind of like plug this in somewhere. I don't know. We'll plug it in right here. I'll say connect freighter. Very cool. Greeting. All right. So you should see signed in as GA75F. Again, let's go ahead and see exactly what's happening here. Connect freighter. Again, you see in the script side, we're importing is allowed, set allowed, and get user info. The way that we're illustrating or like showing the public key is that we're saying this async function set logged in. We're saying the inner HTML is going to be the public key, right? And all the public key is the function get user info. All right, so that's a little bit about defining the functions on the component, right? Using Astro to kind of demonstrate demonstrate some calls, right, without calling the blockchain. And then also integrating Freighter, Stellar's kind of like primary wallet. Well, Stellar doesn't have a primary wallet, so to speak, but the in-house developed wallet, Freighter. This we went over how to connect that to the front end itself, and we see that being reflected here. All right. So you guys have been with me for about 30 minutes, but we're gonna keep it going. All right. We're gonna keep the session going. As I said, every time I do one of these, I kind of like exceeds my expectations. So we're gonna switch gears a little bit. We're actually gonna go to a more advanced smart contract kind of like undertaking, if you will. And what we're going to do is I'm going to share with you the Sorbonne or Stellar, excuse me, example DApp. So let's say Stellar, Stellar example DApp. All right, and I'll just do a quick little note, bash.sh. All right, so if you want to clone the example DApp, all you have to do is run git clone, and you're going to say this guy right here. I don't have the link handy, but you can clone the example DApp by going to this link right here. And I guess I could show you guys what's going on here. All right, here's the Sorbonne example DApp. You could see that it has a README. It needs to be updated actually, but it's a full stack boilerplate DApp that we aim for you guys to use this to create your own crowdfund applications. It's got a bunch of use cases particular to public goods funding, and we'll see how we can kind of tweak this to aim it towards a project outside of the original use case, which is to raise money for an art distribution. And we'll see what we could do here. So without further ado, let's just go ahead and kind of like dive into it. Again, if you're interested in following along, you can run the command git clone and then plug in the link here. And if you want to just check out the repo, you can check it out at the Stellar repo / Sorbonne example DApp. All right. Now, this is one of my favorite DApps because it's one of the DApps that I learned very early on. So I hope my enthusiasm spills over and through the airwaves, so to speak. And yeah, hope you guys learned something today. So let's go ahead and dive right in with the smart contract. First things first, you see some attributes you may be familiar with from the last session. Contract, contract implementation, is a new one. Contract type is a new one, maybe. Token, address, env, into val, and then val. So we'll explain, we'll dive into these as we go through the contract, but I may gloss over a few things for the sake of time. Here you see the public enumeration data key, and this is where you're going to hold a bulk of the keys for the contract storage. Remember, as from the last session, each key has a value, and each value is defined as a certain type. Deadline, recipient, started, target, token, user address, and recipient claimed are our keys. And we'll go ahead and see what different types belong to these values a little bit later. Moving on, you see that we have the state of the smart contract here, and it's just going to be defined by 3 values: running, success, and expired. Now let me do a quick backtrack. I know I said that this example DApp was for a crowdfunding application, and it is. So some of the components behind the smart contract are that it has a deadline for the campaign to run. It has a recipient to receive the deposits for the campaign, the crowdfund campaign, the token that it's going to receive for contributions. It's going to keep track of the users that contributed, and then it's going to give some Boolean values of whether or not the target has been reached, if the recipient claimed, etc. And these states define the or this enumeration defines the state of the campaign. So it can be either running, it can be successful. If it didn't reach the target, then it will be expired. All right, so we have our getter and we have our getter functions here, also known as utility functions. They're just retrieving certain data. Here you see that we're retrieving data from the ledger. We're getting the timestamp, and here you see that we're just retrieving the value for some of the keys. All right, so these are our getter functions, and we also have our setter functions, which are mostly defined here, but they're called actually in the initialize function. All right, so let's go ahead and take a look at the initialize function. You see public function initialize passing in the recipient uh, value, which is an address, deadline value, which is a U64, target amount, which is going to be the amount that you want to get into the deposit or get into the campaign via deposits, the token address, which is the address of the token that's being transferred from the depositor wallet to the crowdfund contract. All right. All right, so let's go ahead and just step right through. So first things first, we're going to assert that the contract storage does not already have a recipient, because if it does, that would say, or that would tell the user that this contract is already initialized. Contract can't be initialized if you want to call the initialize function. We're just going through our setters here. You see eStorage instance set, and we're setting values to all of those keys. You see recipient claimed, started, deadline, target, and token. All of these keys are being attached values that we're passing in through the initialize function. Cool, good to go there. And this smart contract actually consists of two other functions that are kind of like the crux of the functionality behind this entire contract success, really. So this is the deposit function. It takes in two arguments, user and amount. Now, I want to quickly highlight on line 218, you see user.require auth. Now, one cool thing about Sorbonne, the Sorbonne Rust dialect, is that we actually have an authorization framework kind of installed, or implemented rather, in the Sorbonne SDK. So what does this mean? This means that the user has to have the address that is making the call. If I am user A, I can't pass in address B for this call. And this require auth method ensures that the wallet being used to make the call is actually the one making the call. This cannot be another wallet's address. All right. So a simple way to assert that the wallet making the call is using the same value as the address. All right, so you're saying the assertion here, the amount has to be higher than 0, too easy. We're doing some other checks here stating that the campaign is still running. If the sale isn't running, can't make a deposit. All right, so next up, let's take a look at some more interesting logic here. We're getting the user, deposit balance, etc. But let's take a look at line 230. So you see line 230, let client equal token client new. Sorry, where was I? You see let client equal token client new. Where was I? Okay, let client token client new environment, and then token ID. All right, so this is cool because you see token, right? And this is actually a crate that is implemented into the Sorbonne SDK that allows users to kind of leverage this functionality as an interface. So you see token, right? That's the SDK. That is the that's the logic behind the token contract, the Sorbonne or Stellar token contract. You see this client here, which allows you to kind of create like an interface to lay over a contract address. New, obviously creating a new one, and we're laying the token interface over the token ID. So we're going to call different functions via this token interface at a different address. So we're actually going to be making a cross contract call. Cool. Now you see client transfer, right? And we're transferring from the user to the current contract address and the amount. Next, you see contract balance, get the balance, and then we're emitting a pledge amount change event here. All right. So that's simple enough. That's the deposit function. Now let's go ahead and move into the withdraw function. Again, we're defining the state and recipient, doing some checks here and saying, hey, if this sale is still running or if the campaign is still running, cannot make a withdrawal. Again, we're doing the client, or we're defining the token here, calling transfer on the token, transferring it from the recipient, or transferring it from the crowdfund contract address right over to the recipient address. And yeah, moving forward, we're going to set the smart contract storage, set user deposited to 0. All deposits across all, excuse me, deposits across the smart contract storage should be reset back to 0, and the events will be emitted to reflect the changes that were just made. All right, cool. So let's go ahead and see how this works in action. One cool thing about this repo is that it comes set up with some really easy to follow directions. Um, let's go ahead and dive into the package.json file. Here, you could see that there's a reset function that's going to run npm run clean and npm run setup. If we look at npm run setup, all that's going to do is run the initialize.sh script. So I'm going to go ahead and dive into the initialize.sh script, or initialize shell script rather, and just kind of break down what's going on here. First things first, we're going to define a path, a new path for a binary file. That's because we're actually going to be installing the Stellar CLI as a binary file within the project directory itself. That way you can leverage a pinned version of the Stellar CLI to make sure that the kind of tutorial, if you will, or deployment of all smart contracts and front end of the DApp does not fail. It must be pinned to a certain version that is compatible with the Stellar, or the Sorbonne SDK rather. All right, so you see in setup, we are running the initialize.sh file. Again, let's go ahead and dive back into that. Where are we at? Initialize.sh. All right, so that's where we were. Line 9, we're defining the binary path file. That's because we're going to use the Stellar CLI as a binary, right? We'll kind of like gloss over this a little bit. Just know that it is stationed in the target bin directory. Cool, and that's going to run cargo install seller, which is again going to install a pinned version of the Stellar CLI. Real quick, we're going to be able to pass in some values when making the call. If you look at here, we're saying initialize shell, and then we're defining the network as testnet. Excuse me. The script here makes it super easy by allowing us to type in the value standalone, futurenet, or testnet, and we'll kind of have these pre-configured values for the endpoint and appropriate RPC host URLs defined in the script. So when you pass in the argument standalone, future, or testnet, it'll quickly plug those arguments in and define that for you to save you time a little bit later. All right. We're defining a network by using the RPC URL and passphrase. And here, we're actually going to write some of the data, the deployment data, to a folder in the directory called Sorbonne. All right, so that's all that's happening there. Here on line 87, we're generating a new identity called token admin by using Stellar keys. If the Stellar token admin identity already exists, we're going to skip over this. But if not, we're going to generate a new identity using the keys method again. Stellar keys generate token admin, and we're going to do that on the test network. All right, so I'm going to start moving through a little bit faster because we are reaching about 15 minutes out from the hour. So hang in there. All right, so we're defining the Stellar keys address as the token admin. What's it called? Token admin identity we just created through the Stellar keys generate method. We're funding that. This should actually, this is redundant because we actually fund it when calling the generate method. Next up, we're deploying the abundance token, which is just a Sorbonne token. We use this as a mock token for demonstrating a mint and deposit capabilities. After this, so we deploy both the abundance token, so random Sorbonne mock token, and the crowdfund ID. or excuse me, the Crowdfund smart contract. This kicks back a Crowdfund ID, which we then use later to generate TypeScript bindings. All right, so we got some messages here, some success messages that kick back the ID, and then we write that ID to a directory called .sorbon. Last but not least, at the very end of the script, we initialize the abundance token. We give the name abundance, a new symbol, set the decimal places, uh, give it the name abundance, and then we set the admin as the new identity we just recently generated. After this, finally, and last but not least, we initialize the crowdfund contract. We set a deadline for about 1 week. 86,400 seconds is 1 week from now. And we say stellar contract invoke, and we're calling the initialize function. So going through the setter functions again, we're setting the recipient key as the admin address, that's the value, setting the value of the key deadline as the deadline value. Target amount key will be set to the value of, I think this is 10,000 or 1,000 tokens, I believe. And the token is going to be the abundance token that we just deployed. So I say all that to say this, let's go ahead and run npm run reset, and we'll just go ahead and see what happens here. By the way, thank you so much for sticking with me thus far. I know these sessions can be quite long, but I'm really hoping that you guys are learning a lot. And again, really happy that you guys are sticking with me throughout this journey. Real quick, I kind of wanted to do a recap over the freighter connection lesson here. So if you remember, we implemented Freighter through the following ways, right? We actually used the method get user info, right? So if you remember, we used get user info and we returned the public key. That's exactly what we're doing in this application here. We go to the wallet data component. You see use account and use is mounted. Now, wallet data is going to use both of these hooks, but if we go back into use account, doing at the end of the day is using get user info right from the Stellar API, and then we're returning these objects. So that's how we're able to use Freighter to return the public key. And let's go ahead and dive into some of the main functionalities of the front end components that require some of the logic from Freighter to sign some transactions. Yeah, let's go ahead and do that right now. So if we look at the form pledge, I believe, form pledge, is this it? Yes, we look at the form pledge component here. This is actually going to contain a button that's going to allow us to mint the abundance token. So again, that mock token that we're using, this is how we're going to access the mint function. So if you see on click async set submitting equals true, const transaction again equals await abundance mint. And again, we're able to do this because when we create TypeScript bindings, we're creating node modules for our smart contracts, right? So the abundance smart contract has the method mint, which we're able to leverage because of the TypeScript bindings. Again, they have the SDKs installed on the back end, on the backside of the node modules, and they're able to communicate with the Stellar blockchain by kind of creating the calls by hand using JavaScript, all to abstract away development cycles for you and save you time. All right, so we have to, which is the account, and then amount. And then we're defining the public key as the public key that's returned by Freighter, and this is the key that we're using to sign. All right, and that logic continues with both calls. So you see, let me try to track this down real quick. So that was the mint function, and now you should see the deposit function, right? Crowdfund. Let's just go ahead and do a quick search. Deposits is not in this one. Deposits for molecules, deposit. Transaction set balance, prop address. Form pledge, we should see a deposit function in here. Yep. So transaction, Crowdfund deposit, and then we're going to pass in the user and the amount. Same as before, we're calling the public key or a get public key method to pretty much pass in the signer there. And that's going to be because of Freighter. So we're going to say npm run dev. Let's hope everything works. I'm hoping. All right, shared contracts. One second real quick. Let me go ahead and I actually have to run contract bindings. All right, so here we have to run yarn run and say bindings. Okay, so one quick hiccup here. During the deployment process, when we ran initialize, it actually didn't run the binding script. Just full transparency, we're going to be deploying this to Vercel, and there is a quick issue with the original package.json file that comes with the pre-install command. Now, this pre-install command will actually build the TypeScript bindings for you, which is required for the front-end deployment. So I deleted that call, and that's kind of like why we're seeing that error here, because there's no TypeScript bindings for the abundance contract. But let's go ahead and run this dev function again and see if that worked. It should work. Okay. Whew. That was very close. Good thing the demo effect did not get us today. All right. And you can see my wallet address here. This means that Freighter is hooked into, or the Freighter API is hooked into the front end component. So this is reflecting properly. Let's go ahead and try this mint. Okay, so Freighter actually doesn't allow websites that don't have an SSL certificate to make calls. So what we have to do here is we have to transfer this over to a production type of deployment. So stick with me here. What we're going to do is we're going to remove the target, rm.rf targets. All right, so we're going to move the target directory, and we're going to use Vercel to deploy the front end. So I already have Vercel on my machine, but if you don't, you'd have to run npm I Vercel or npm I-G to install Vercel globally. Now I'll just quickly run Vercel. I have it installed globally here. We're going to set up and deploy this app here. We can say yes. Yep. I don't want to link to a project. I don't want to link to an existing project. I'm going to give this a new name. We're going to say Sorbonne example DApps, so sed, and we're going to say 07, for July. So sed 07. We're going to go ahead and deploy this, set up the project here. All right, we don't want to modify any of these settings, so we'll say no. And we're going to go ahead and wait for this deployment to kind of build and be set up to production. It's going to take a little while. All right, just kind of waiting for a quick sec. I do want to open this up to the side to make sure that there's no problems. I don't think it should have an issue. Make sure Freighter is logged in. All right, we're logged in. GA7 CKTV. Whew. All right, so the deployment is ready. It did not crash. and you can actually access it through this URL here. So I'll be happy to share that. Let's go ahead and connect wallet. All right, so first time connecting to a website, Freighter is going to send this pop up and say, "Hey, do you trust this website?" I'm going to go ahead and connect it. I did click connect, but it doesn't look like it was updated. So I'll do a quick refresh. You can see my public key being illustrated here, being displayed here. I'm going to go ahead and click the Mint 100 Abundance Token button. All right, and look at that fee, 0.189. All right, so Stellar is about zero point 0.1 cents right now, right? So 10 cents. And zero point 0.1, I mean, you got to imagine that is such a low fee. And that can really help out startups and just users in general, right? Why charge users an arm and a leg for fees? All right, so that call went through, and you can see that the balance has been updated to 100 abundance tokens. So that was the mint function. And again, just quick recap because I'm super proud of this. We went through the mint function earlier, right? Mint function will say, where are we here? Amount input, pledge. I'm so hyped, I can't even remember where we were. Uh, okay, so amount input, author info, button, connect button, deposits, right? Whoops. So let's just say .mint. All right. So here we are in the form pledge. Excuse me, everyone. But again, I was super excited, couldn't figure out where we were in the code, but this is where we want to be. Line 49 in the form pledge file into the molecules directory. You see const transaction equals await abundance mint, and that's what we called right from the front end when we called the mint function right from here. This is all the logic that happened. We passed in the account, which was determined by connecting with Freighter, and the amount, which is predetermined within the code itself. So we're just saying the amount is going to be 100. All right. So now that we have 100 abundance tokens in our balance, go ahead and back this project with 100 abundance tokens. Let's go ahead and review the call, and then we're going to see here that the contract is receiving the tokens and the sender is going to be the address or the wallet that we're using, and we're going to be sending 100 abundance tokens. So we'll go ahead and approve and continue. We'll sign the transaction, and we'll hope it goes through. Boom. The campaign has made, or we've made a 100 abundance token deposit right to the campaign, and we have concluded the campaign itself because our goal was 100 abundance tokens. And yeah, as you can see, this was updated in real time because of the subscription hook that is actually in the boilerplate itself. All right, so that is my time. In conclusion, I highly suggest that you guys check out the docs. That you can find them at stellar.org/developers. And if you guys have any questions, then please, please, please join the Stellar Discord. There is a developer channel there. There's also a help channel there. And we are always ready to answer any of the questions that you guys have along your Stellar development journey. Once again, my name is Julian Martinez, Once again, my name is Julian Martinez, Senior Developer Advocate and Common Man here at SDF. Again, thank you guys so much for being with me, weathering the storm. It's been a great hour of diving into DApp development. I hope you guys learned something. And until next time, take care.